Here we go, 6D, directions and bearings. When we're working in Ex6D, they usually use what we call true bearings. Sometimes they use a capital T to let you know it's called true bearings. What is true bearings? True bearings just basically means that no matter where you are on the compass map, you will always start in a clockwise direction. Okay, clockwise, so going from right to left. Clockwise direction starting from north. No matter where you are, you always have to start at north. So north is the only one compass. Okay, the one starting point. So true bearings are usually written using 3 digits. So for example, 45 degrees, notice that it is written as 045. However, that NE there, they don't write that. The NE is just for you to know that it's northeast, but technically it shouldn't be there. Because true bearings just rely on the numbers, the digits, and you already know that you start from north and you go clockwise up until you reach where you need to. So they could say a true bearing of 135 degrees, so they'll use a capital T, and they'll say true bearings 135 degrees. So this is called true bearings. And that is equivalent to, now think about where 135 degrees is. It's right over here. So I'm just going to circle it. 135 degrees is over here. That's starting from north, and you're moving all the way clockwise to get to this direction. Okay, so I'm starting with my compass like this, and I'm moving 135, so that's 90 degrees, 135 to point in that direction there. That's what 135 true bearing means. The S and the E there, this is now called the surveyor's compass or surveyor's bearings or conventional bearings. So I'll just write here conventional bearing. Conventional bearing is when they actually tell you that they start from south or north. In this case, you can actually go from south and you go, how many degrees would it need to be if this is 135 over here? So this is 135. What would this angle here have to be, yes, Sam? 45. So this is, remember they have to add up to 180 degrees because from north to south is 180 degrees. So that means I'm missing 45 degrees. So in a conventional bearing, you can say south 45 degrees. And then when you say east, it tells you that you're heading towards east, but starting from south to 45. So conventional bearing, you can go anti-clockwise or clockwise. So you go southwest, southeast, or northeast or northwest. You never start with west and you never start with east. Okay, so you never say east 45 degrees south. That's not how we speak. We normally say south or north. That's what conventional bearing. But most of the problems that you're going to deal with is usually written in true bearings. So they just give you a 3-digit number with an actual angle, and that is assuming that they always start from north and they go clockwise. So far, so good? All right, let's do a problem together. And remember, this is going to be true bearings, not conventional bearing. Here we go. We've got A, B, C, D are 4 points as shown in the diagram. Give the true bearing. So they want a true bearing of each point. And this is going to be key. What makes exercise 6D tricky is this word, from. Because the from tells you where you should be thinking, where the north actually starts. So they say from the origin. Can you see where O is? They've actually drawn the compass right exactly where O is. So that compass that I just highlighted in blue starts where O is. If they said from D or from A, then your compass now moves to where A is, because north begins at that point. So the word from is the hint where your compass starts at. And that's where a lot of students make the mistake. Okay, you will need to use some parallel properties to solve those kind of problems. But we'll start off with the questions where true bearings of each point from the origin, because from the origin is easy. Usually the diagram is pretty self-explanatory from the origin. So let's start off with the first one, A. So if I wanted to find the angle from O, okay, so from O to A, so from O to A, this is O to A. See, I'm starting, the compass is starting from O, north is starting from O, and I'm going towards A. What is this angle that's missing here? What should that be, Sanvi? 60 degrees, because I know that from east, or E to A, that angle's 30, so E to north is 90 degrees, so 60 is the missing angle for it to be complementary. So what would the true bearing be? The true bearing from O to A is equal to 0, 60 degrees. Remember, 3 digits. Write in 3 digits and people understand that you're writing in true bearings. Let's go with the next one. What about from O to B? So from O to B, I'm just going to rub this one off now. So O is here, so this is the north. You're always starting from north and you're going all the way to B. What would this one be? Yes, Yuna.
140 degrees.
And how did you get 140 degrees?
90 plus 50.
Okay, very good. So we know again, this is 90 degrees. Northeast is 90 degrees, and you have an extra 50 degrees. So 90 plus 50 gives us a total of 140 degrees. And that'll be the true bearings from O. The keyword's from O. What's the true bearings from O to C? Can I please have, let's go with Toby. From O to C. So I'm looking at that massive reflex angle there. 110. Has to be more. 250 degrees. And one quick way to see is that we know that from north all the way to west, that's 3/4 of the way. So it should be 270 degrees minusing that 20. So if you actually did 270 for the 3/4 turn, minus the 20, that's the gap between west and C, then that gives you a leftover of 250 degrees true bearings. Last one, D. What is the answer for D? Let's go with Sean. 310, let's see. So we know that all the way here is 270 plus an extra 40. Yes, that is 310. So 270 plus an extra 40 gives me 310 degrees starting from north. Okay, so this is what I said. This is the one that most students will pick up. The one that most students tend to make a mistake is when I change the word from, and it's not from the origin, but it's from a different point. So let's try B now. B has 2 that I'm testing. Let's have a look. So this time I'm saying, what is the bearing from A? Because it says from A here, and I'm trying to get to O. So O from A just means from A to O. If you can switch the language there. So when they say O from A, really the key word is the word from. So you're starting at A, and you're moving towards O. So here we go. Here's your diagram again. I normally draw a compass to help out students to picture this. So I actually draw a parallel line to the north. That parallel line is key. Yeah, that parallel line tells me now I'm starting at A, and sometimes I do a dotted line just so that I know where the 90 degrees are, roughly, to see what I can figure out. You're trying to go from A, I'll do another color, A, all the way to O. Now, O is over here. This is the line that connects A and O. So I'm actually working at a reflex angle here. The question is, how do I work this one out? This is what makes it a bit trickier. So if I draw the line further down, now we know from north to south, that's 180 degrees. What I'm missing is that little corner here. This little bit just in between, right there, that's what I'm missing. That's what I don't know. What can we use to figure that out?
Corresponding. Well, I'm not sure what it's called, but since it's 30 degrees, wouldn't the other side be 30 as well?
Ooh, okay. You are 30 is here and you're saying that there. Yes, that is correct. That's alternate angles. If this is 30 degrees, this is 30 degrees here as well. So you think about if I drew the parallel lines again. What Sanvi is saying is if 30 is here, this is 30 up here. That's called alternate angles. Okay, so yes, that's 30. That parallel line with the transversal line that cuts through, these two are alternate. So if you know that's 30, we can quickly work this one out because this gives you that 90-degree visual aspect to it. So if that's 90 degrees, this must then be 60. So I know this little bit here in this triangle, that must be 60, but I already know that from A to here is already 180. So I can say it's 180 plus an extra 60. That means the answer is 240 degrees true bearings from A to O, or if they said O from A. There's a lot of other ways to do it. If you knew, you could use co-interior as well. So if you've forgotten the co-interior angle, I'm just going to show you. Two parallel lines, so north and north. If you draw a line that cuts through, these two angles must add up to 180 degrees. They're supplementary. So A plus B, those two angles there inside the parallel lines. So A plus B must be supplementary. That's also another method as well. So we found out before this was 60. So 60 plus what gives you this angle here? 60 plus 300. So then you can work backwards and subtract. Yeah? So that's another way to do it as well. But either way, you're going to have to use parallel properties to solve those kind of problems. Have a go with the next one. O from D, I'm going to give you, let's give you 3 minutes to have a go. It's 220. How do you work out the angle from from D to O? Or they say O from D. So I'm going to rub this one out again, and we're just going to look at the diagram again. Your goal is to think about O from D. So D is the new compass point. Got to think of the north line starts there. So how do you get to O? That's what you're trying to figure out.
You start from north. And you want to clockwise start.
Yeah, I know. But it looks like most people are done. It was only 1 minute, actually. Oh, didn't you? All right. So, let's have a look. You're going from D to O. So you're looking for this angle right here. We know that this little bit here is 50 degrees. Using co-interior properties, these two angles must add up to 180. Therefore, the angle from D to O should be 130 degrees. Hands up if you got this correct. All right, well done. Very good. So the answer for part B from D to O is 130 degrees true bearings. All right, flip over to the next page if you haven't done so already. Let's look at the last example, example 2. For these problems, draw the diagram. Here we go. I got a ship that travels due south. What does due south mean? Down, so directly down. That's what due south means. Due south means directly south. So going exactly down. So you're going down, starting at a point. So when I draw it, I just draw a dot. And I say that's O for the origin. I go directly down, so I draw a vertical line down. And I say that is 8 kilometers. And then on a bearing, now this is key, when they say then, on a bearing of 160 degrees, that means this is the new spot now. This is my new point. So I started at O, and I landed at this first point A. That is where the new compass begins. Okay, so as you're doing questions where there's multiple turns, every new point is a new compass. All right, you just got to think you put a compass there, and north is always going to point due north. All right, so here it says on a bearing of 160 degrees. That means in my mind, I'm picturing a compass that sets up right at A. They said 160 degrees, so I clearly know it's going to be passing the east direction, and I know I'm moving somewhere into this second quadrant, or technically fourth quadrant. And so that means when I draw the line, I know it's going to be something like this. 160 degrees. When I do these kind of problems, I normally do it in quarters. So since I know it's 160, I know this is 90. Then I say, well, how much more do I need to make an extra 160, in total 160? This must then be 70. Okay, so I like to split it up so that I can do some calculations later on. So that's 160 degrees on the true bearing. They told me that we're doing 160 degrees for a distance of 12 kilometers. So that means this one here is 12 kilometers now, and then I reach whatever the next point is. Now this problem is relatively easy because there's only 2 instructions. The ones that I've done before in the past has 3 instructions. So then from here, you might then do a 270 turn, so you could end up going that direction. Okay, so the better you draw the diagram with your parallel lines in your north direction, the easier it is to calculate. But for now, we're just working with 2 instructions. So vertically south, and then on a true bearing of 160 degrees. Let's answer the first one. It says, how far east? So we know east is usually in this direction. So north, never eat soggy Weet-Bix. Okay, so east is in this right direction. What it's asking is, how far horizontal, so from point B, how far horizontal is it from its starting point? Starting point is here. So horizontally east, this is how far I need to work out. I need to work out how far east horizontally is my ship currently. If I draw it out and I actually connect the dots, you should then be able to see there's a right angle triangle coming about. See, I'm actually just working out for this length here, which I'll highlight. This is the length I want. I've got a right angle triangle just within that region there. That's pure east and that's due south. So that must be 90 degrees here. If you drew that triangle out more carefully, technically, you've got 90 degrees. This is what you're trying to figure out horizontally. And you've got a hypotenuse of 12 kilometers. And you know this angle here is 70 degrees. And that's what I mean by breaking up the angles. It helps you to see what you're working with. If you stuck with the 160, it would have been a bit confusing. But you break it up in the quarters, you see that 70 degrees, that's my triangle. Then now you can use SOHCAHTOA to work out x. So let's go. 12 kilometers my hypotenuse. What is x representing? Let's go with Mira. Adjacent. So which function or trig ratio should I be using? Let's go with Sahaj. Co. That's very good. So SOHCAHTOA. So it must be cos of the angle is equal to adjacent divided by hypotenuse. I've got the angle 70 degrees. Adjacent is x. Hypotenuse is 12 kilometers. To work out x, what do I have to do, Toby? I want to get x. So how to get rid of this divide 12?
Times both sides by 12.
Beautiful. Times both sides by 12 because times is the opposite of division. 12 divided by 12 cancels out. So you will get on your calculator whatever x, or x is equal to whatever on your calculator, 12 times cos of 70. They say correct to 2 decimal places. All right, let's check. So on your CAS calculator, if you got something like mine, go to trig. Whoops. Cos 70 degrees. Make sure your mode is in degrees. So check the mode. Is it in degrees? 70 degrees times by, what was it, 12. Control Enter. You get 4.1042. Hands up if you got that answer. Very good. Round to 2 decimal places should be 4.10. So you should have, therefore, x is 4.10 kilometers east from the starting point. Okay? Let's try B now. B is saying how far south is the ship from its starting point? So again, the starting point is all the way up here, and you're looking for how far south. So it means you should be calculating all of this distance here. Now we know this first bit, that's 8 kilometers. This one tells us it's 8 kilometers from here to here. All we're missing is this vertical height of your triangle. So if I draw the triangle again, we know this is 70, this is 12, 90 degrees. You're trying to find the vertical height. Hopefully this time you notice that it's hypotenuse again, but this is opposite. So which function should I be doing? Let's go with Raha. Sine, very good. So you should have sine of the angle is equal to opposite divided by hypotenuse. Sine of 70 degrees, y divided by hypotenuse is 12.
Oh.
And same thing as what Toby said before, to get rid of that divide 12 times both sides by 12. And on your calculator, you need to work out what 12 times sine of 70 degrees is. But remember, that's not your final answer. We've got to add on that extra 8 kilometers that we're missing. So let's go. 12 times sine of 70 degrees. Oh yeah, that's in the exact value. But remember, you need a plus on 8 as well. Control Enter. A total of 19.276 kilometers. That's including the extra 8. Yeah? Well, if you want to work it out individually, this should give you 11.276. Okay? Plus on the extra 8. So this is 11.276. And then when you add on, so the total south length must be 8 plus whatever 12 times sine of 70 degrees is. Notice that I used the exact value and I didn't use a rounded answer. If you round your answers early in your calculation, your final answer will be a decimal off. So don't do that. It's okay to finish your answer here, but if you're going to continue on, you should use the exact value in your calculator. Okay, so don't use 11.28 because then you'd lose on the other decimal points. Okay, so if you wanted to calculate it properly, you should be typing that into your actual calculator. Okay, so I did that before. I did 8 plus, and I know it says 12 cos 20. They're just complementary angles, something that you won't need to know now. But sine and cosine, they're always going to add up to 90. So sine of 70 will be the same as cos of 20. You can test that out. You can try like cos of 50, then it'll be sine of 40. They're always going to equal. Okay, they're complementary angles. Anyways, so the answer should be 11.28 kilometers as your final answer. So 19.28 kilometers south. Very good. So that's like the preliminary expected questions. The harder questions will have multiple instructions, so 3 or more. But just being able to do 2 is a good start. All right, team, I'll stop the video there. This is now your time. Next session is 6I. It's going to be new. If you want the notes, I have printed them out early. They're here. If you want it, let me know. We'll go through that on Wednesday.